As requested by some of your classmates, may I present the solution to one of the problems in the quiz. If tangent of xy equals x, find dy over dx. Looking at the form of the given, it is trigonometric and at the same time implicit. Therefore, to differentiate it, we have to make use of trigonometric differentiation and implicit differentiation. The left side of the equation is tangent xy. And from our rules on trigonometry, from our formulas for the derivatives of trigonometric functions, derivative of tangent is secant squared. So, derivative of tangent xy is secant squared xy, and from our chain rule, we differentiate xy, which is a product, as the first factor x times the derivative of the second factor y, which is dy over dx, plus the second factor y times the derivative of the first factor, derivative of x equals 1. So times 1 equals derivative of the other side of the equation, derivative of x equals 1. Okay, and by multiplying this to each term inside the grouping sign, to get the product, we get x secant squared xy dy over dx plus y secant squared of xy equals 1. Then we have x secant squared of xy dy over dx equals 1 minus y secant squared xy. Okay, and then getting rid of this factor, we divide the whole equation by this to get dy over dx equals 1 minus y secant squared of xy all over x secant squared of xy. Now if you stop here, you might say the answer is not found among the options. However, if you do further simplification, you'll end up with letter B, because we can express this in terms of cosine. How? Now we try to divide both numerator and denominator by secant squared xy. Okay, so let's divide the numerator by secant squared xy and also the denominator by secant squared xy. Are we changing the original fraction? No, because this is just the same as multiplying by 1. It's like when you deal with a fraction, for example 10 over 15. To reduce this into simplest terms or lowest terms, we divide both numerator and denominator by 5. And that is equal to 2 over 3. So we employ the same process. Okay, we divide both the numerator and denominator by exactly the same expression, in this case, which is secant squared xy. So what happens next? This is what happens when we divide both numerator and denominator by secant squared xy. This one becomes 1 minus y secant squared xy all over secant squared xy all over the denominator x secant squared xy over secant squared xy. Okay, so where did this come from? That take the numerator divided by this. Okay, and then denominator divided by this. There you have it. Okay, however, in the denominator, obviously, there is a common factor. We can cross it out right away, this with that. Okay, and how about the numerator? Let's simplify further our numerator. Take note that I can break this apart into two fractions, just like if you have a plus b over c, you can rewrite this as a over c plus b over c, isn't it? Okay, since their denominators are alike anyway or are the same, then you just combine the numerators, a plus b all over c. Or if you have a plus b all over c, you can break this apart into the sum of these two fractions. So let's apply that here. We can write this as 1 over secant squared xy minus y secant squared xy over secant squared xy. So let's write it down. 1 over secant squared xy minus y secant squared of xy all over secant squared of xy all over our denominator. What is left in the denominator? Just the expression x. Okay, now what is 1 over secant squared? Take note that 1 over secant xy is cosine of xy. Why? Because secant and cosecant are, or secant and cosine rather, are reciprocals. This is in fact the same as 1 over cosine of xy. And so when we get the reciprocal of the denominator, that's 1 times cosine of xy. Okay, so please do not forget this. 1 over secant of xy equals cosine of xy, your reciprocal function. Now let's continue. What then is 1 over secant squared xy? This must be cosine squared of xy minus, looking at the second term, we have a common factor. So we can cancel this out, leaving y all over. What remains in our denominator is x. Okay, and can you find this among the options? Yes, it's in fact letter B. Okay, so it's letter B, which is the correct answer. For the open-ended part, the problem is find f prime of x if f of x equals 2 over r cosine of the square root of x. So how shall we differentiate this? First of all, you have to rewrite the given into 2 r cosine of the square root of x raised to negative 1. Okay, so the given could be written in this manner. And take note that this is of the form u raised to n. Okay, u raised to n, which is the generalized power rule, in which our u is r cosine of the square root of x. Recall that if a function takes the form u to the n, then its derivative y prime is equal to n u raised to n minus 1 times du. Okay, so in this case, our u is our cosine of the square root of x. Okay, so to differentiate then our u, use one of the rules in differentiating an inverse trigonometric function. The derivative of our cosine of x is 1 over the square root of. Take note that our u here is an inverse trigonometric function. So to differentiate it or to find du, we have to use the formula for our cosine, which is negative 1 over the square root of 1 minus x squared. Or a more general case is that, okay, derivative of our cosine of u equals the negative of du over the square root of 1 minus u squared. So let's apply that here. Du becomes negative 1 over the square root of 1 minus u squared, in this case square root of x raised to the second power times. Okay, applying chain rule, we still have to differentiate the square root of x. And the square root of x is the same as x raised to 1/2. Therefore, applying product rule, its derivative is 1/2 x raised to negative 1/2. Okay? So, du then equals negative of the square root of 1 minus x. Okay, where did I get x? X is obtained after squaring the square root of x, or after raising the square root of x to the second power, because that one will eliminate the radical sign here. Okay, so now we have the square root of 1 minus x. What about this? Okay, we can bring this here. So instead of writing 2 right after the radical sign, I'll write 2 here. And x raised to 1/2, x raised to negative 1/2 rather, becomes over the square root of x. Okay, so let's go back to our original function. F prime of x then equals, from our generalized power rule, if we can express the given into u to the n, then y prime will be n, there you have n, u to the n minus 1 times du. Okay, so f prime of x equals, bring this down, it becomes a factor to be multiplied to 2. So, negative 2 times cosine, our cosine of the square root of x raised to negative 1 minus 1 times the derivative of this, which is negative 1 all over 2 square root of 1 minus x square root of x. Okay, so let's simplify further. What happens with 2 and 2? And what about with negative 1 multiplied to negative 1? Okay, so what will the product be? F prime of x becomes 1 over, how about this? This will give our cosine of the square root of x raised to negative 2. But if you want to express it into a positive exponent, then we have to write this in the denominator. So all over our cosine of the square root of x raised to the second power times our du. Okay, times du, or times, we have already du here, so we can just copy. This is positive 1 now because that's after multiplying negative here with the negative here. So positive 1, and we just copy the other factors, which are the square root of 1 minus x, the square root of x. Now you might ask me, what if the order of the following are disarranged? It's alright. You may have this written first, followed by square root of x, followed by this, or the square root of x, followed by this, and followed by the first factor here. It's okay because these are factors anyway. And by commutativity of multiplication, the order does not matter. Okay? Or you can express even your final answer as f prime of x equals 1 all over. You can multiply the 2, giving the square root of x minus x squared, and then we simply copy this. Arc cosine, okay, arc cosine of the square root of x Okay, so the answer will be 1 all over. You may multiply the 2 here, giving a product of the square root of x minus x squared, okay, times arc cosine of the square root of x raised to the second power. Okay, so that's it. Now, however, I saw some of your solutions in which they made use of the quotient rule. It's okay. So let me just show that too. F of x equals 2 all over arc cosine of the square root of x. So some of you have assigned this to be the u and this as the v. So taking the derivative separately, u is 2 and its derivative, of course, this is a constant, is 0. V, which is the denominator, is arc cosine of the square root of x. And so it's dv then, applying the laws or rules for for inverse trigonometric differentiation, is negative 1 over the square root of 1 minus the square root of x squared times, okay, from chain rule, derivative of the square root of x is 1 over 2 x raised to negative 1/2. So let's simplify this further. This becomes negative 1 all over the square root of 1 minus x, okay, after multiplying square root of x to itself, or after raising square root of x to the second power, the radical sign is eliminated. Okay, so that's it. And then here you have the factor 2. So I may write 2 here, and x raised to 1/2 is the same as the square root of x. Okay, so I think we are able to make use of the quotient rule. So by quotient rule, f prime of x is equal to, if your function takes the form u times v, then y prime is equal to u dv minus, if your function takes the form u over v, then y prime is equal to denominator times derivative of the numerator minus numerator times derivative of the denominator all over the square of the denominator. So let's apply that here. F prime of x therefore equals, okay, v du u dv. V is this. Okay, so r cosine of the square root of x times du. Du is 0. Okay, once more, du is 0. Times 0 minus, okay, minus u times dv. Okay, times u, which is 2, times dv, which is all of this. Okay, u times dv. U, what is u? 2. And what about dv? It's this one. So 2 times negative 1 all over 2 square root of 1 minus x square root of x. Okay, all over the square of the denominator. The square of the denominator. Do not forget that. So, r cosine of the square root of x raised to the second power. So that when this is further simplified, okay, this one, since we have a factor 0, this will be 0. And then what happens with the negative sign? Negative times a negative is positive. And 2 with 2 here will cancel out. Okay? So, we are to cancel out 2 here and 2. And what happens to the sign? Negative times a negative is positive. Okay? So, let's continue further. F prime of x equals positive 1. Okay, 1 over 1 over the square root of 1 minus x square root of x all over r cosine of the square root of x squared, but could be written as f prime of x equals 1 over the square root of 1 minus x square root of x times 1 over r cosine of the square root of x raised to the second power. Okay, so you may have it written in this manner, or 1 over the square root of x minus x squared r cosine of the square root of x raised to the second power. Okay, let's compare it to our previous answer. Are they the same? Okay. Okay, so compare the two. They are equal. So you can make use of the quotient rule or the generalized power rule for this problem.